are used to make indentions in soft materials such as leather or plastic in order to create a starting point for a cutting or drilling operation. Extractors are used to remove screws, bolts, or other fasteners that are stuck, damaged, or stripped. Drifts are used to align holes in materials such as metal plates or pipes in preparation for fastening or welding. Hammers come in various shapes and sizes and are used for striking and shaping materials. Spanners are used to tighten or loosen nuts and bolts and come in various sizes to fit different types of fasteners. Each of these tools has a specific purpose and is used in repair work to help make the necessary cuts, indentations, and fastenings. It is important to choose the right tool for the job to ensure the repair work is effective and safe. We look into the tools in this video.
At the end of this demonstration, you will be able to note the types of spanners, the types of hammers, use of extractor and punches. Tools required: hollow punch, drift, extractor, hammer, cross pane hammer, straight pane hammer, single-ended spanner, double-ended spanner, Tommy bar. There are a lot of tools used in repair work. Some of the major types of tools used in fitter job are as follows: hollow punch, drift, extractor, hammer. Now, let's see each types in detail. Hollow punch. A hollow punch is a hand tool used to make a clean circular hole in soft materials such as leather, plastic, or rubber. It consists of a cylindrical shape with a hollow center and a sharp edge used to cut out a circular piece of material. The punch is placed on the material and struck with a hammer to cut the hole. Hollow punches are commonly used in leather working, upholstery, and arts and crafts. A hollow punch is a useful tool for fitters in various applications, including pipe and tube fittings. It can be used to create holes in pipes or tubes for threading or welding. Sheet metal fabrication. It can be used to create holes in sheet metal for fastening or mounting. Drift. The drift tool in a fitter refers to a tool used to adjust or align components or parts in a fitting or assembly process. It is usually a long, thin tool with a pointed or rounded end that is used to gently nudge or move the parts into the correct position. The term drift tool is commonly used in metalworking, automotive repair, and other fields where precise alignment is necessary. The primary use of a drift tool in fitter is for adjusting or aligning components or parts in a fitting or assembly process. Some common uses of drift tools in fitting include aligning holes or dowel pins. Drift tools can be used to align holes in metal plates or parts so that dowel pins or fasteners can be inserted easily. Straightening bent parts. Drift tools can be used to gently push or hammer bent parts back into the correct position. Removing or installing press-fit components. Drift tools can be used to remove or install components that are held in place by a press fit. Adjusting gears and pulleys. Drift tools can be used to adjust gears and pulleys to ensure proper alignment and smooth operation. Aligning pipes and tubes. Drift tools can be used to align pipes and tubes during installation to ensure that they are properly positioned and supported. In summary, drift tools are versatile tools that are commonly used in fitting to align and adjust components and parts to ensure precise and accurate assembly. Extractors. Extractors in a fitter refer to tools used for removing or disassembling components that are stuck or difficult to remove. They are often used to remove broken screws, bolts, pins, or other fasteners that have become lodged in a component. Extractors come in a variety of sizes and shapes and can be used with a variety of tools such as pliers, wrenches, or vices. There are several types of extractors, including spiral extractors. These have a spiral flute that is designed to grip and remove broken screws, bolts, and pins. Left-handed drill bits. These drill bits are designed to back out screws and bolts rather than cutting into them. Easy-out extractors. These are similar to spiral extractors, but they have a hexagonal shape that allows them to be used with a wrench or pliers. Stud extractors. These extractors are used to remove broken studs from engine blocks or other components. Hammers and spanners. Hammers and spanners are two common tools used by fitters. Hammers. Hammers are used to strike or apply force to components during the assembly or repair process. Hammers are used for striking purpose such as straightening bent parts, setting or removing nails, or tapping components into place. Claw hammer, used for removing nails and demolition work. Ball peen hammer, used for metalworking striking purpose such as shaping and bending metal. Mallet hammer, a soft-headed hammer used for striking purpose that require a non-marring blow such as woodworking. Spanners. Spanners are tools used to tighten or loosen bolts, nuts, and other fasteners. They come in a variety of shapes and sizes and can be used to grip the heads of bolts, nuts, and other fasteners. Some spanners are adjustable, allowing them to be used with different sized fasteners, while others are designed for specific sizes and shapes. Types of spanners: single-ended spanner, double-ended spanner, Tommy bar spanner. Both hammers and spanners are essential tools for fitters as they are used in many different tasks and applications during the assembly and repair of components. They are designed to help fitters apply force and adjust fasteners with precision and accuracy, which is essential for ensuring the proper functioning of assembled components.
Let's have a recap of what we have learned today. We have learned to select the holes for repairing, use the types of spanners, use the types of hammers, use of extractor and punches. Thus, we have learned the use of hollow punches, extractor, drifts, various types of hammers and spanners for repair work. Hope you have a clear understanding on this. Do this exercise with the help of your instructor.
Hello everyone. Today's video will teach you how to erect simple machines.
Objectives: at the end of this video, you can be able to erection of lathe machine, erection of drilling machine, erection of power hacksaw machine, testing the machines after erection. Let us briefly discuss on lathe machine. A lathe machine is an equipment that uses a tool that may be fed deeply into the workpiece and travel across it to remove unwanted material from spinning workpieces in the form of chips. One of the most adaptable and frequently used machines in the entire globe is the lathe. The mother of all machines is another name for the lathe because it enables a wide range of operations. The lathe machine has evolved into a general purpose machine tool used in manufacturing and repair work. The lathe machine's numerous components include bed. The lathe machine's bed serves as the framework for mounting all of the other components. The bed is supported by large box section columns and is made of cast iron or a nickel cast iron alloy. The guiding and sliding surfaces are present and its upper surface is either scraped or grounded. The bed is made of hefty metallic slides with forced ways or vesses along their length. Cross grids provide rigid support for it. Headstock. On left side of the bed, there is a headstock. Power transmission to the various components of the lathe is the headstock's primary duty. It correctly assigns and supports the main spindle inside the bearing. Additionally, it contains a gearbox system that is required, complete with levers for changing speeds. The following items are mounted on the headstock spindle: 3-jaws chuck, 4-jaws chuck. Tailstock. Tailstock is a movable casting located opposite to the headstock on the way of the bed. The basic function of the tailstock is to support the other end of the work when being machined. To hold a tool for performing operations like drilling, reaming, taping, etc. It consists of the dead centers, the adjusting screws and the hand wheel. The body of the tailstock is adjustable on the base, which is mounted on the guideways of the bed and can be moved to and fro. Carriage. It is located between headstock and tailstock. It is used to hold and move the tool post along the bed either towards or away from the headstock. It slides on the guideways. It is also made of cast iron. It has 6 main parts: saddle, cross slide, compound rest, compound slide, tool post, apron. Saddle. It is a casting in the shape of a H that is fixed on the lathe ways and supports the cross slide that moves the tool post. Cross slide. During machining, a cross slide on the carriage enables the movement of a tool post at a right angle to the bed guideways. The feed screw moves the cross slide. Combination rest. A component that joins the cross slide and the compound slide is called compound rest. On top of the cross slide is attached the compound rest. It is manually controlled and does not get any power. Rotating the compound rest feed screw can be used to adjust the cut depth. The compound slide is securely locked with the base once it has been adjusted as necessary. Composite slide. The dovetail joint secures a compound slide to the compound rest. Angles or tapers that can't be cut by turning the headstock are cut using compound slides. Tool post. The compound slide stop is fastened to the carriage. It is used to rigidly hold the tools in the proper position. Apron. The carriage is equipped with an apron. It consists of the carriage's whole driving and controlling machinery. Feed devices that supply the carriage with automatic feed are used to secure the apron to the saddle. Chuck. It is a crucial piece of equipment that is utilized to hold and turn the workpiece. A chuck is capable of holding even the smallest bit of work. Faceplate. The faceplate can be job installed to carry out the turning operation and is fixed to the lathe spindle. Center. A center is a component of a lathe machine that supports lengthy tasks between the headstock and the tailstock during a lathe operation. A live center is a center that inserts into the headstock spindle and revolves alongside the workpiece. Feed shaft. It is constructed of high-quality alloy steel. It is positioned beneath the lead screw and extends the full length of the bed. There is a keyway where commands can be sent to move the carriage for the feed mechanism. The power feed gives the tool cross movement when it is attached. Lead screw. It is employed for cutting thread. The lead screw, which is located on the bed's bottom side and utilized to move the carriage automatically while thread cutting is there. It has Acme threads and is composed of high quality metal. Legs. Legs are utilized to support all of the machine's loads. They are anchored to the ground to stop vibration. Chip span. Chip span is placed lower side of the bed. The main function of it is to carry all chips removed by the workpiece. Hand wheel. This is the wheel that is operated by hand to move a cross-slide, carriage, tailstock and the other parts that contains a hand wheel. Speed controller. The speed controller is located on the headstock, which controls the speed of the spindle. Bull gear. It is made from cast iron. It is used for slow and fast speeds by means of a bull gear backpin and is fixed by a key on the hollow spindle. Sleeve. Sleeve fits inside tailstock, which can be moved back and forth to fit or remove dead center. Erection of lathe machine. A lathe is a machining instrument mostly used for shaping wood or metal. It operates by having the workpiece revolve around a cutting tool that is fixed. The primary function is to remove the material's undesirable positions, leaving behind a neatly shaped workpiece. Select the space for proper functioning of machines such that machines normally must be conveniently accessible. Prepare the foundation plane as per the manufacturer instruction. As per the plan, foundation can be made. The following fundamental specifications for machine foundations must be met. The foundation must be strong enough to support the superimposed loads without failing through shear or crushing. The settlements should be within the permissible limits. As much as practical, the combined center of gravity of the machine and the foundation should be in the same vertical direction as the base plane center of gravity. To prevent resonance, the foundation soil system's natural frequency should either be too high or too low compared to the machine's operational frequency. It is recommended that the natural frequency be high for low-speed devices. A machine's rotational and reciprocating components should be perfectly balanced to reduce any imbalance forces or movements. Insert the holding down bolt before this foundation sets down. According to the weight of the machine, the depth of the foundation be made. Machine may be placed in position for leveling and aligning. To ensure that floors, ceilings and other surfaces are properly horizontal, leveling is also essential. Skipping the leveling procedure results in poor quality work, leading to crooked surfaces that are highly vulnerable to earthquake damage. Before setting the foundation, a foundation bolt inserted through the holding down hole in the basic of the machine. After setting the concrete, the machine is put on the foundation bolt in floor. Align the machine perfectly horizontal position using spirit level. The spirit level is applied to certain measuring areas both in longitudinal and cross direction. Insert wedges must be driven into the gap under the machine bed. After inserting wedge, check the level using spirit level. Grouting is carried out by pouring creamy mixture of almost pure cement. After setting grouting, the wedges may be removed. The machine base is then tightly screwed to the foundation bolts. After tightening the nuts, the correct position of the machine must once more be checked by means of the spirit level. Connect the power supply to the machine with the appropriate specification of circuit breakers. Finally, do the practical test and geometrical test. Practical test. The actual test jobs are prepared on the machine and the accuracy of the work created is then checked. Geometrical test. Verifying the sizes, forms, locations and relative alignment of components are all parts of geometric testing. They cover all operations such as planeness, alignment, axis intersections, parallelism and squareness of straight lines or planar surfaces. Safety precautions. When loading, slings should be protected from sharp-edged by packing softwood. Before lifting, ensure the load is securely slung before taking the lift. When unloading, make sure that you have a firm foundation for your stack and make provision for the removal of slings without disturbing the stack. Let us discuss how to prepare a foundation plan for lathe machine. Objective. This shall help you to mark foundation layouts. Select the space for the erection of a center lathe machine. Mark points at a distance of 1 m maximum from the pillar or wall. Draw the baseline with the help of twine thread dipped in chalk powder or chalk solution. Construct the vertical baseline using 3-4-5 method as in a right angle triangle. Mark the total base area of the machine. Draw the central line of the base horizontally. Locate the position of the holes. Mount and level machine on anti-vibration pads. Objective. This shall help you to level the machine on anti-vibration pads. Lift the machine by crowbars and place wooden blocks under the machine at all the 4 corners. Select suitable anti-vibration pads depending upon the weight of the machine. Remove the leveling bolts from the metal casting. Mount anti-vibration pads under the machine. Fix leveling bolts to the metal casting through the foundation holes of the machine. Lift the machine slightly by crowbars and remove the wooden blocks from the machine. Level the machine both in longitudinal and transverse directions using a precision spirit level of accuracy 0.02 to 0.05 mm per meter. Position the carriage in the middle of the bed. Keep the spirit level on the rear slideway, that is, the slideway opposite the operator's side longitudinally at the position A. Keep the second spirit level transversely at the position C. Take the readings of both the spirit levels. Adjust the level of the bed till both the spirit levels show the same readings. Keep the spirit levels longitudinally and transversely at positions B and D. Adjust the level of the machine as required by screwing or unscrewing the leveling bolt. Finally, check the level of the machine with the spirit level. Lock the position of the machine by leveling lock nuts after completion of work. Recap.
In this video, we have learnt about the parts of a lathe machine and discussed how to prepare the foundation and erect the lathe machine. I hope after watching this video, you can be able to erect a lathe machine. Thank you for watching. Have a wonderful day.
Hello and welcome students. In this topic, you are going to learn about the machineries used in the welding trade.
Objectives. At the end of this exercise, you shall be able to learn the names of the machines used in welding trade. See the machines virtually in the form of photographs and identify them by names. Understand the machinery and its parts. Know the uses of each machinery used for welding process. Now let us identify the machinery in your workshop. Arc welding transformer, oxyacetylene plant setup, MIG welding setup, TIG welding setup, plasma cutting, DC power source rectifier, pedestal grinder, submerged arc welding, electro slag welding, laser beam welding, plasma welding, thermite welding, friction welding, portable circle cutter, resistance welding, Seam weld. Portable cutting machine. Magnetic particle testing kit. Spot welding. Electrode drying oven. Die penetration test kit. Arc welding transformer. An arc welding transformer is a machine used for arc welding, which is a welding process that uses an electric arc to melt and join metal pieces together. Oxyacetylene plant setup. An oxyacetylene plant setup is used for oxy-fuel welding and cutting. MIG welding setup. MIG stands for Metal Inert Gas Welding, also known as Gas Metal Arc Welding, GMAW. It is also known as a Metal Active Gas, MAG process. It is used to join metal pieces together by melting and fusing them with an electric arc formed between the wire electrode and the workpiece. TIG welding setup. TIG stands for Tungsten Inert Gas Welding, also known as Gas Tungsten Arc Welding, GTAW. It is commonly used for high-quality welding applications, providing precise control and producing clean welds. Plasma cutting. Plasma cutting is a process that uses a plasma torch to cut through electrically conductive materials such as steel, stainless steel, aluminum, and copper. DC power source rectifier. A DC power source rectifier converts alternating current AC into direct current DC by using diodes or other electronic components. It is commonly used in welding applications where DC power is required, such as for certain types of arc welding processes. Pedestal grinder. Similar to a bench grinder, a pedestal grinder is a machine used for grinding, sharpening, and shaping metal objects. Submerged arc welding. Submerged arc welding SAW is a welding process that utilizes a continuously fed consumable electrode and a layer of granular flux to shield the arc and the weld pool. Electroslag welding. Electroslag welding ESW is a welding process used to join thick materials, typically plates or sections with thickness ranging from 25 mm to several meters. Laser beam welding. Laser beam welding LBW is a high-precision welding process that uses a laser beam to melt and join metal parts together. Plasma welding. Used for precise and high-energy welding, providing high welding speeds, narrow and deep weld penetration, and excellent heat control. It is used for welding metals including stainless steel, aluminum, and titanium. Thermit welding. Also known as exothermic welding, it uses a chemical reaction to join metal parts. It is commonly used in railway applications for welding rails together and is known for its high strength and durability. Friction welding. This process creates a strong bond between two metal parts by generating heat through friction and applying pressure. It is used in various industries for joining similar or dissimilar metals. Portable circle cutter. A tool used for cutting circular shapes in metal sheets or plates. It is commonly used in fabrication shops, construction, and metalworking. Resistance welding. A welding process that uses electric current and pressure to join metal parts. It is widely used for spot welding, seam welding, and projection welding in automotive, electronics, and manufacturing industries. Seam weld. A type of resistance welding used to create continuous welds along the length of a joint, commonly used for joining sheets or tubes in industries such as automotive and aerospace. Portable cutting machine. A handheld tool used for cutting through various materials including metal, plastic, and wood. It is normally used in construction, metal fabrication, and demolition work. Magnetic particle testing kit. a kit used for non-destructive testing to detect surface and near-surface defects in ferromagnetic materials. It utilizes magnetic fields and magnetic particles to identify flaws in components. Spot welding, a resistance welding process used to join two or more metal sheets or parts by applying heat and pressure at specific points. It is widely used in the automotive industry for joining sheet metal parts. This process is used for the similar and dissimilar metal joining. Electrode drying oven, used for drying and storing welding electrodes to prevent moisture absorption, ensuring the quality of the welding process. Die penetration test kit, a kit used for non-destructive testing to detect surface defects and discontinuities in materials. It involves applying a colored dye and examining the surface for penetrations indicating flaws in the material. Now let us discuss the important points in identifying the machines used in the trade. Repeated reading of machinery and its name is useful for identifying the machines. Practical knowledge of handling the machine will enhance the machine usage. Point out important usage of the machine before using it. Handbooks of machines will always be helpful for the beginners.
Recap. Let us do a quick recap of what you have learned from this topic. Identify the machineries used in welding trade. See the machines virtually in the form of photographs and identify them by names. Understand the machinery and its parts. Know the uses of each machinery used for welding process. Thank you, students. Let us meet in the next session. Bye. Hello, welcome students. In this topic, you are going to learn about the welding trade, safety equipment and their uses.
Objectives. At the end of this exercise, you shall be able to identify the safety equipment, mention the name of the safety equipment, mention the uses of the safety equipment, record the name and uses of respective safety equipment details in the table. Now let us look at the safety equipments. Fire/flame resistant clothing, aprons, rubber-soled safety boots, safety shoes, insulated gloves or chrome leather gloves, welding helmet, hand shield, goggles, earmuffs or earplugs, respirators. Let us see the preparation for identification of safety equipment and their uses. Task 1. Read and interpret the personal protection equipment visually on real devices or from the charts. Fire or flame resistant clothing, aprons, rubber-soled safety boots or safety shoes, insulated gloves or chrome leather gloves, welding helmet, hand shield, goggles, earmuffs or earplugs, respirators. Task 2. Identify and select the personal protection equipment suitable for a particular type of protection. Protects from flying particles or debris. Kits welding helmet. Fumes and oxides. Hot slag, sparks. Goggles.
Protects from
heat, fires. Kits, fire or flame-resistant clothing.
Protects from
Noise, earmuffs or earplugs.
Protects from
Electric shock, insulated gloves or chrome leather gloves.
Protects from
Burns, rubber-soled safety boots or safety shoes. Now let us see the hazards and the respective safety equipment used in the welding process. Write the name of PPE to corresponding type of protection.
to protect from
Heat, fires. Kits, fire or flame-resistant clothing.
to protect from
Kits, aprons.
to protect from
Electric shock, heat, burns, fire. Kits, rubber-soled safety boots or safety shoes.
to protect from
Electric shock or heat. Kits, insulated gloves or chrome leather gloves.
to protect from
Flying particles or debris. Kits, welding helmet.
to protect from
Irritation and chemical burns. Kits, hand shield.
to protect from
Intense light. Kits, goggles.
to protect from
For noise. Kits, earmuffs or earplugs.
to protect from
Fumes and oxides. Kits, respirators.
Let us do a quick recap of what you have learned from this topic. Identify the safety equipment. Understand the safety equipment. Uses of safety equipment. How to record the name and uses of respective safety equipment details in the table. Thank you, students. Let us meet in the next session. Bye-bye. Hello and welcome, students. In this topic, you are going to learn about how to perform hacksawing, filing square to dimensions.
Objectives. At the end of this exercise, you shall be able to identify the various parts of bench vise, how to use the bench vise, describe the method of hacksawing, filing to maintain squareness and dimension of edges. Now let us see the tools and equipments required for hacksawing, filing square to dimensions. Marking media, steel ruler, scriber, prick punch or dot punch, ball peen hammer, flat file, bench vise, hacksaw, tri-square, personal protective equipment PPE. Check the pre-machined size of 75 mm length and 75 mm breadth using a ruler. Use marking materials 82 mm maintaining side B mark. Similarly, mark 82 mm on side E. Punch the marked line. Hold the job in the bench vise, keeping 10 mm away from the marked line. Make the notch on the line to start hacksawing. Cut along the marked line. Similarly, cut on the other side. Apply pressure in the forward stroke. Release the pressure in the return stroke. Use full length of the blade while sawing. Clamp the job to allow sawing towards the overhanging end. Clamp the job to be cut according to the cross section for sawing. Hold the job as flat or as long as you can so that it can be cut rather than the edge. Tighten the jaws firmly to avoid tilting and shifting of the job. Clamping needs improvement to reduce chattering and vibration. Now let us see how to perform filing and to maintain square dimensions. Task 1. Hacksawing. Select the correct pitch blade for cutting. Shorter the cutting section, the finer the blade pitch. Make sure that at least 4 teeth are cut at a time. Harder the material, the finer the blade pitch should be. Fix the blade such that the cut direction is towards the teeth. The wing nut is used to tighten and tension the blade. As long as only a few teeth are cutting, use a small amount of downward palm pressure. Only when cutting forward, use downward pressure. Use the full length of the blade in order to avoid early dulling of the teeth in the middle portion of the blade. Move the blade strictly in line with the marked direction. Avoid tilting the frame during cutting because doing so could cause the blade to bend and shatter suddenly. Cut from the opposite side if deviation exceeds the marked line. To avoid breaking the blade and hurting yourself, cut slowly while finishing the cut. Task 2. Filing square to dimension. Check the height and the bench wise to select a platform or another workbench. Hold the job in the bench wise with a projection of 5 to 10 mm from the top of the wise jaw. Select the files of various grades and lengths according to the size of the job, quantity of metal to be removed, and material of the job. Verify that the file's handle fits tightly. Using the palm of your right hand, press the file forward while holding the file's handle. Hold the tip of the file according to the quantity of the metal to be removed. For heavy filing, for light filing, for removing the local unevenness, draw filing can also be done. The same filing can also be done for fine finishing. Start filing by uniformly applying pressure to the file while moving forward and releasing it while moving backward. Give a few more strokes to make sure that the file always stays flat and straight across the surface to be filed. Balance the file's pressure. Checking flatness. Use the blade of the tri-square as a straight edge for checking flatness. Place the blade of the tri-square on the surface to be checked in all directions so as to cover the entire surface. Do the checking face. The light gap will indicate high and low spots. Checking squares. Consider the large finished surface as the reference surface. Ensure that the reference surface is filed perfectly and is free from burrs. Butt and press the stock against the reference surface. Bring down slowly and make the blade touch the second surface with which the squares are to be checked. Light gap will indicate the high and low spots.
Let us do a quick recap of what you have learned from this topic. Identify the various parts of bench vise. How to use the bench vise. Describe the method of hacksawing. How to do filing to maintain squareness of the edges and maintain the dimension. Thank you, students. Let us meet in the next session. Hello and welcome students. In this topic, you are going to learn about marking out on MS plate and punching.
Objectives. At the end of this exercise, you shall be able to prepare the job as per size 150 mm length, 100 mm width and 3 mm thickness. Explain what is marking media, copper sulfate or chalk powder solution. Explain how to put a straight line using steel ruler and scriber. Describe the uses of prick punch and pitch. Tools required for marking out on MS plate and punching. Marking media, steel ruler, scriber, prick punch or dot punch, ball peen hammer, flat file, bench vise, hacksaw, tri-square, personal protective equipment PPE. Now let us see the preparations for using media marking on MS sheet. Take a 3 mm thick MS sheet for this job work. Clean the sheet with wired wool and remove the dirt and dust on the sheet. Mark the cutting edge of the job as per size 150 mm length, 100 mm width and 3 mm thickness. Use the shearing machine to cut the job piece according to the marked size. Check the edges for smoothness. Make the square edges by filing. Check the squareness using tri-square. Keep the job prepared for punching and marking after the testing the squareness. Apply copper sulfate or chalk powder solution and allow it to dry. Keep the sheet in flat position on the workbench or work table. Using steel ruler and scriber point, mark points A, B, C, D, E and F from the 150 mm long edge of the job at 10, 25, 40, 55, 70 and 85 mm distances. Similarly, mark points A1, B1, C1, D1, E1 and F1. The edge of the steel rule may have been damaged. To avoid wrong measurement, coincide or set the first or second cm graduation mark of the steel rule against the 150 mm long edge of the job for taking measurements and marking of points A to F and A1 to F1. Ensure there is no parallax error while using the scale to mark the points A to F and A1 to F1. Using the steel ruler and scriber, draw the lines AA1, BB1, CC1, DD1, EE1 and FF1. Draw towards you while tilting the scriber in the direction of the stroke. Punch small holes on each of the 6 lines with the dot punch and hammer. While hammering, hold at the extreme end of the handle. Visually check the marked lines for parallelism and correctness. Pitch is the distance between the 2 consecutive dots.
Let us do a quick recap of what you have learned in this topic. Prepare the job as per size 150 mm length, 100 mm width and 3 mm thickness. Explain what is marking media, copper sulfate or chalk powder solution. Explain how to put straight line using steel rule and scriber. Describe the uses of prick punch and pitch. Thank you students. Let us meet in the next session.